Alrighty, having a look at the Gen Nano. Going to do a quick intro just to the device, and I'll go into a bit of testing. What we want to see is normal stuff, battery capacity, have a look at the board, the build quality, do a charge cycle on it, see how well it charges. Vaporesso has been pretty good for charging so far. The Gen was quite good. So let's have a look. I'm always interested to see if they've overrated the battery, because it happens all the time. They just so let's just put another couple hundred milliamp hour on there. No one will notice. It'll make it sell better. And then it's not inside. It's not that milliamp hour battery. Hate it when that happens. Okay, so first thing we'll do is we'll get it apart. Well, not first impressions, but impressions from using the device. Not real keen on this style of device. I won't bag the Gen Nano because it's kind of done everything it should, from a little baby built-in battery device. I'm reaching over here because I'm getting the Gen S. It's just like they've hit the scale down button on their CAD drawings and then gone, yep, that'll do, just print that. Just a cute little version of the Gen. Well, I mean, it's Gen Nano, so it's living up to its name, isn't it? The tank, I can't taste anything out of the tank. It's not really any flavour for me. The liquids I use for the DIY liquid, I don't know. It tastes pretty decent out of the NRG S tank from Vaporesso, and the Mesh, sorry, not Mesh Pro, Fire Loop 3 from Freemax is my favourite. Seems to be the best in that. Off this little guy, it kind of just, I can't really taste much of anything out of it. And I think because of the lower amount of vapor you get out of it, you'd need to up the nicotine a bit, which I haven't done, so kind of not really getting the throat hit, and the flavour isn't really there, so I don't know. You might be better off with a nice little mouth to lung or something you could put on here and actually get some good good vaping time out of this battery, because at 55 watts, this little guy is not going to last very long. 2000 milliamp hour. Man, that's kind of pushing it. Like, I always think it's just a weird size of device where it's like it's bigger than what you'd want for a super small mouth to lung. I mean, it's still tiny, but I mean, it's not like a pod system, for example. And it'll do high-ish wattage. So the maximum is 80 watt, which just, like, don't run it at 80 watt. It's just going to last 5 minutes. It's going to be rubbish at 80 watts. There's no point doing it. And I can pretty much guarantee it will be drawing too much current for the size battery it's in there. 80 watts out of one cell, that's a lot of current. We've got to be talking over 30 amps off the top of my head. And that's not where you want to be. So I think it's too much for the cell. I think that 80 watts, like a lot of these little devices, it's just marketing. Just don't run it at 80. I think even 60 is probably struggling. At 60, you're going to be charging it like 2 or 3 times a day at least if you're using this as your only device. So if you can get something that runs at like 20 or 30 watts as a little restricted direct lung, or even better, a mouth to lung that's running at like 10 to 15, yeah, cool. It's going to be a great little device, and should last you all day at that lower wattage and not stuff the battery. So I think that's where you want to be on one of these. I think it's just dumb trying to run it, you know, those high wattages. Okay, we'll get onto it. There's enough talking. Ooh, that'll work. Should have had that out to begin with, you idiot. Luckily, 2 little screws on the bottom here. Often with the internal cell devices, they do tricky stuff, hide screws behind panels, or hidden screws, or no screws, and the thing's just glued together. And that's no fun for me, or someone who likes to take stuff apart, because then you got to destroy the thing to get it into it. There's a good cracking noise and a bad cracking noise, and sometimes you don't know which is which until later on. Yeah, we'll look inside and see what you've broken. Nope. Yeah, there it goes. Okie dokies. That's a different style of lipo or internal pack that I normally see. A lot of the mods I've taken apart, I was going to say recently, but not so recently. So a lot of the internal cell mods I've taken apart have had these sort of cylindrical cells, which they're basically like it's basically like an 18650 or 21 or whatever size, the internals, but without the metal case. So these little guys here, I mean, it's the same thing, it's just wrapped up a different way. So little block of a lipo in there. Not sure the chemistry. They seem to favor lithium cobalt, but it'll be probably like some sort of hybrid chemistry special mix to get the characteristics they want out of the cell, which for us is, annoyingly for us, is kind of we want everything. We want the highest capacity and the highest discharge rate we can get. So, you know, they got to make a compromise and land somewhere in the middle. But hopefully, first of all, they select a battery that can handle the current, because that's our kind of safety indicator. And then go for the highest capacity cell they can get that's going to meet that. So that looks like that's actually 2 parallel cells. You can see in there, nice amount of sort of dielectric tape cardboardy kind of adhesive. A couple little bits of plastic there, again to kind of make sure nothing's going to touch against the case. In this particular instance, it doesn't really matter if it touched against the case because it's plastic, it's polycarbonate. So it's kind of a bit odd, but I guess, no, odd. Don't know why they'd worry too much about that. A bit of leftover stuff from the hand soldering there. Got a funny little component down there that's covered in blue stuff. Don't know why. Micro USB socket, as they mostly all are. Well, they're actually going towards USB-C these days. So looking at it, it's a very small, very shallow micro USB. It actually looks a bit shallower than normal. Yeah, right. So there's 4 attachment points, which you'd hope for when they lay them flat, the sockets flat on the board. They then got enough space to be able to get 4 attachment points. That's important just because it needs all the strength it can get. Every time you plug and unplug, it's going to be flexing this outer cage. That's what always fails on them. And in this case, well, yeah, because it's lying flat against the board, they have taken advantage of that. Done 4 attachment points. There's kind of 2 on the sides of that USB socket, and then on the back there's 2 as well. And they look like they're kind of through hole as well, because I can see they're there, and then back in there, back in there. So that's decent, that's good. As far as liquid ingress protection, fairly minimal. So push the button. Oh, there's no, there's not much to stop. So there's always going to be gaps between the buttons. We saw on the Free Max. Bring this guy over. On the Maxis, you've got this rubber plate at the front here. So then you've got kind of a membrane in between. Oh, got parts flying everywhere. Little membrane in between the switches, with the outside of the device, the buttons that sit on the outside that you actually press. And there's a rubber layer, and then underneath is the board. So if you do get some liquid that goes in between the button and the case, it's going to sit on the outside here and not go directly onto the board underneath. Which, you know, if you get enough in there, it's gonna get all inside and eventually get down into the board, and there's a gap there for the screen. But it's kind of that's extra protection, which is good because liquid getting into mods it's just going to kill them. Conformal coating helps on the board, but it's not going to stop, not going to completely prevent it. So, and there's really not much going on here. There's no rubber plate like on the Maxis. Yeah, so you can see, like, when you push the button, say you spill liquid down the front, push the button, or it just gets, it's going to sort of capillary in between that gap there. It's going to go inside, and there's a MOSFET right there, which can get triggered by juice and switch on and cause auto firing or the mod to have a meltdown. And there's no conformal coating on this board because it's just dry. Dry board, no coating, not really any ingress protection there. At least on the screen, it's got the cover flush with the case, which is good. The ones like anything with a recessed screen is no good, because you can't wipe the liquid off it and it gets in there. Sort of like we'll have a look at this SX500, the Yeehy GTRS. I mean, let's see how recessed the screen is. So if you spill liquid, it's just going to go in here, and you can't get it out. So like, what do? You know, if you only need one atomizer to have a little leak, like you've haven't used it for a little while, and they absorb moisture into the liquid through the airflow, and it kind of soaks up and pulls in there. You know, if you've ever left an atomizer for a couple of weeks, you come back and you tip it on its side, and suddenly liquid pours out. It's because it's hygroscopic, one of them. The liquid, the VG in the liquid is hygroscopic, sucks in the moisture, gets watered down, ends up pulling in the bottom here. You know, if you leave it too long, it will just start flowing out the airflow holes. And over your mod, you don't need that to happen once, and it's going to get down into those recessed screens. So that is decent at least, but no good with the buttons. No protection really there to stop liquid getting in and around and onto the board, and the board's dry, so there's no conformal coating to protect it in that instance either, which is not great. 7.4 watt hours, which always messes with my head converting it. That should be 2000 milliamp hour. Yeah, 7.4. Yeah, okay, so that's decent. That at least the internal cell is rated at what the device is rated at. So thank you, Vaporesso, for telling the truth and not trying to fudge the numbers. So that's I like that, but I mean, that is just a label. So we'll stick it on the CBA, the cell tester, and we'll see if it's actually delivering that capacity, and we'll also see what sort of current it can handle. So these little pouch cells, yeah, I mean, it just depends on what kind of cells they are. So we'll see if it can handle the current. What I can do is jack it up to 80 watts, put an current shunt into the input, see how much current it draws, like maximum amount of current the board can draw, and then I can plug that into the software for the CBA and do a discharge at that rate, and just see how badly the cell is getting treated at that high current rate. I think it'll be pretty nasty. I mean, if you think about the cell at 3 volts, say, like right down at sort of minimum, at 80 watts. So what's that? 80 divided by 3 is a lot. Times inefficiency. So yeah, probably around about 30 amp. That's going to be off the top of my head, because if it was 90, it'd be 30 amp. Times 10%, 88 watts. So yeah, it's going to be just under 30 amps. Wow, that's a lot of current for this little cell. It's got the same kind of mounting system as the Gen, the full-size Gen, with this weird little, yeah, it looks the same on the outside as well. That could be the same component, actually, just a different plate. Yeah, the 510, it's got this little weird back cap on it that seems to go over this frame, but I have no idea how that can actually go together unless it's internally threaded. So yeah, it's got the same as the Gen. I haven't heard any reports of these falling out yet, but relatively new mod. There's a little silicon guy there, but that's not gonna stop anything because it's not flush up against the bottom of that switch. Yeah, so that's probably more for actual fire button feel. Little rubber doobie around the screen, just to make it fit nice, I guess, and stop it rattling. Just give it a bit of protection. Shouldn't be any liquid getting through there anyway, so that's not really for ingress. And it's got the same size buttons for the up, down, and mode as it has for the fire switch, which I like to see And again, going to use the, can I? Can't really see it, damn it. Oh yep, I can. Using the Freemax Maxis as an example, if you have a look at the fire switch there, is a lot bigger than the up-down buttons. Because obviously you're not going to use the up-down buttons anywhere near as much as the fire button. And I think that looks like a little sealed switch as well, so liquid can't really get into it. So heavier duty switch and just a lighter duty switch on the up-downs that don't get used very often is what Freemax went with. For Vaporesso, they've used the same size switch, little, you know, just your little typical surface mount tactile switch. So not super impressive for the fire switch. And especially those two MOSFETs sitting right there next to the biggest gap, which is around the fire button. Biggest gap where liquid can get through around the fire button goes straight out to these MOSFETs, and that makes me nervous, especially with no conformal coating. Because if you look back a little while, what happened with the Vupu drags, that's exactly what was happening. Liquid was getting in, flowing down onto the MOSFETs. It was causing them to turn on. Well, this is the theory, which I'm relatively sure is correct. Causing MOSFETs to switch on when the liquid's been sitting on them for a little while, because they don't need really any current to turn them on. And making the boards completely fry, and basically what would happen is the whole battery current would just get dumped through that shorted MOSFET or switched on MOSFET when it was switched on at the wrong time, and would cause the whole mod to have a complete meltdown. And if you're lucky, you're there and you can throw the thing out the window so it doesn't burn your house down. If you're unlucky, yeah, if it's sitting near anything flammable, things aren't going to go well. So I don't mean to scare you, but that's just not great. Those MOSFETs just sitting right next to the fire switch, right where the fire button is, and the liquid can get through. Yeah, it's not a great deal else to tell you about the device. There's a little slot that the board sits in, but other than that, there's obviously no screws retaining the board itself. Apart from it just sitting there really, and having the outer case kind of just hold it in. So there's nothing super impressive about the construction on this guy. There does actually look to be a little bit of shininess down this end of the board. It's going to be real hard to see on camera, but these components from here down look shiny, and these guys at the top are dry. Like they've selectively coated the bottom of the board. Why would you do that in particular? That other side, this whole side's dry. Just down the bottom there might be a reason why they thought, maybe they thought liquid could get in through the USB port, so you better do a little bit of coating down here, but that's all we can be bothered doing. I don't know, man, that's a bit weird. So the other trick I can do, see if this is going to work, just to see if there's any conformal coating, is a UV light, because the coating, yeah, the coating will often react to UV light. So let's turn the lights out, see if we can see this. Okay, I'll take a picture of that and I'll put it up on the screen now. Yeah, so I reckon that looks pretty cool. You can clearly see the conformal coating, little bit of a coating they put on the board there, very selectively, just in one area. Like they've decided those components right there need to be protected, but we don't care about any of the other MOSFETs and power components up here that can short out from juice. Weird. Weird. I would say that's charging circuitry down there, but mean, there's no particular reason why that's more important to protect than the rest of the board as well. And we'll just go into the testing. So first we're going to have a look at the internal cell testing. There's two discharges shown here. The first one, the red line, is the capacity testing. So this is done at a very low rate, actually 400 milliamps in this case, which is a C/5 rate. And this is just a nice slow discharge to see the maximum capacity of the cell. And we've got 1983 milliamp hour, which is pretty good. That's what we were hoping to see since it's a 2 amp hour cell. It would be nice to see that a little bit higher. If the manufacturer had been using sort of like a minimum capacity as they're rated, then we would see this a little bit higher, so you know, around about 2050 or 2100. But I think close enough, 1983 milliamp hour. Yeah, we'll call it a 2000 milliamp hour cell. So that's good to see that Vaporesso is not doing anything dodgy and you know, overrating the device and making it look better than what it is, because obviously capacity is quite a big selling point for these little internal cell devices. You often buy them based on what capacity they say they've got. So the second discharge I've done here is the green line, and that's a max discharge test. So what we want to see here is how it performs under heavy load. Now I chose 25 amp in this case. The device itself will actually draw up to about 30 amps with a dead flat battery, but you know, looking at the other results I saw in testing the DC converter, it was more like sort of 22 to 25 amp throughout most of the discharge range. So yeah, I was pretty happy with 25. So it actually held voltage pretty well. This is better than what I was expecting. This is the underload voltage here. So what we'd see with a cell that is sort of massively underrated for current is the voltage will just get dropped, pulled down right down to sort of 3 volts almost instantly if it's you know, a very low discharge cell. And the fact that this cell has managed to hold up, I mean, starting at 3.5 under 25 amp load, that's a pretty big load, and this is a tiny little cell. I think it's actually done surprisingly well. So it's obvious that Vaporesso has, you know, probably chosen the cell to be a high discharge model. They haven't just thrown any old sort of 2000 milliamp hour cell in there, because if it was just a storage cell like you'd see for you know, a really low current device, it just wouldn't give you any output at all. It'd just sag straight down to 3 volts. Mainly it's because their internal resistance is very high for the high capacity cells, or the you know, the storage cells. So yeah, pretty good. We still got 1897 milliamp hour, which is pretty surprising. It's only 100 milliamp hour off the capacity test, and that's at cranking out 25 amps. Now the temperature is one thing that's a bit of a concern. It's pretty high, 84.1 degrees C max. That was right down just as it hit 3 volts. That's sort of too high for this 25 amp to be the cell's continuous discharge rating. The 18650s and 21700s, batteries like that, the hybrid chemistries often will rate 80 degrees C as the max for their operating current. So you can reasonably say once they've hit that, they're sort of at that current rate is their maximum continuous. In this case, since it's a LiPo, you know, I don't know the actual chemistry of the cell, assuming it's like a lithium cobalt cell, probably more like 60 degrees C, a lot lower is the maximum you'd want to see on it. So that temperature is going to hold it up from being able to say it's a 25 amp cell. I'm thinking probably 15 to 20 amps would be kind of an equivalent continuous discharge rating for the cell, which is still really high. That's pretty impressive for this little cell. That also does mean though that running it at the 80 watts, the full 80 watts, is going to push it. You know, it's really pushing the cell. Still, it's over what you'd want to run it at. So yeah, I mean, that's my opinion. Is I wouldn't run this mod at 80 watts. I wouldn't run it flat out all the time. I think if you're using anywhere near that level, say 60 watt, 50, 60 watt and above, you just need to get a bigger mod or a dual cell mod, something like that. You're just not going to get very good performance out of it. But having said that, Shouldn't be too scared to use sort of 50-60 watts if you want to. I just wouldn't run it at the 80 full time. So here's some data I got on the USB charging function on the Nano, and this was with my homemade Arduino rig. So what we're seeing here is in blue the battery voltage rising as it charges through a cycle. Right at the end here is the cutoff, so you see the cell voltage drop down to start to relax, and the currents, both the USB and cell currents, drop off. Throughout the cycle we're looking at pretty steady current regulation, not too bad, a few little blips and things going on, but it's really inconsequential. We're looking at over 3/4 of an hour sort of thing, so these aren't like any sort of quickly changing levels, no big deal. Pretty high current rate, looking at around about 2.2 amp maximum for the cell, which is pretty high for a 2000 milliamp hour cell. That's over a C rate, so that's pretty hard on it. Over the long term, that might cause, or it probably will cause, extra wear compared to charging it at a lower rate. So they're really prioritizing getting this device charged as quickly as possible, rather than ultimate number of cycles that you're going to get out of it, or how many charges you're going to get out of this device. Now it's all looking really good, apart from just down here, this little section here where the cell current is actually going negative. So what that means is that the board is drawing some standby current from the cell. It's not coming from the USB. So the board is staying sort of partially active while it's plugged in, but after the cycle, which means it is pulling the cell down and it will gradually discharge it. Now I'll just go on the next graph, it will show this a bit better. So in this cycle, it's just on a much longer timeline. So the whole graph we were looking at before is just in this little first part. So this is extended up over, I think 9 hours or close to 10 hours this was. So what we're seeing is the cell voltage just dropping slightly. You can see down here also the cell current in the negatives. That means slowly discharging the cell. And the voltage dropping at about the 4-hour mark. The charge circuit decides, okay, cells dropped too far, I've hit my auto recharge level. So it kicks back in. You see the current spikes here. It's kicked back in to top that cell up. And that's just going to keep repeating as long as the device is plugged in. So that's not ideal. Like, it shouldn't really do that. It should go to 0. The board should go into a full standby mode where it's not drawing any current, or if it does need to stay in standby mode for some reason, it would be nice if the USB current was supplying it, but that does involve extra circuitry to do that. So just a little issue there, but I mean nothing too drastic, because if you're using this device as your daily, you're probably going to be unplugging it shortly after, and good practice, you should always unplug anything charging. Once it's done, you see it's done, you know it's going to take around about an hour or whatever. Just plan to unplug it after that time. Just don't leave it all day unattended, especially don't leave it overnight if you can. You should be getting to this 1 hour, 1.5 hour mark, and that's it, you unplug it there. So in that case, in that sort of usage case, this little discharge and top up thing doesn't really matter too much. Actually, wouldn't really make any difference at all. So it's not too big a deal. But so efficiency, actually the circuit was really high. It was 85% to 88% throughout the cycle, which is excellent. And the main benefit of that high efficiency is that the circuit isn't generating a whole lot of heat. Let me just check my notes here. So it was maximum temperature I measured on the board during charging, which was about halfway through the cycle. Let it charge for a good while before testing it. 68 degrees C at the inductor and the converter, and the voltage converter, and 63.1 C at the case of the switch mode IC, and that's fine. That's pretty good. So that means these components aren't going to be getting too stressed by running at high temperatures. They're going to have a higher reliability compared to another device that's hitting much higher temperatures. Yeah, so good on Vaporesso for putting a switch mode converter and charging system in the Nano. I think that's really good. It's probably going to be pretty difficult to see all these numbers or make too much sense of them, but this is some brief testing I did on the DC converter. So the DC converter inside the mod is the part of the circuit that takes the battery voltage and changes it into what you want for your atomizer. So if you're setting 20 watts, that converter has to bring the voltage probably down to suit that fuel atomizer, or up if you want to run at 80 watts, it'll actually have to boost the voltage from the batteries up to a higher level. So that's the purpose of that circuit. Now we want to have a look and see, first of all, if it's accurate, what it's putting out to the coil. Slightly unrelated, similar, is the resistance, what it's actually reading, and what the coil is. And probably most interesting is the efficiency. So this is showing you basically how much energy it's wasting of your battery power. So that's fairly important for that you're getting the best battery life. If you're running at very low efficiency, you're going to be using a lot of battery life to not get a whole lot of vaping time. But thankfully these days, and as far as regulated mods have ever been built with switch mode converters, they're pretty good. They're all around about 90% mark. So first, having a look at the resistance, the indicated resistance is very, very close to the actual resistance. 1.09 to 1.1, 1.10. Pretty good. Happy with that. 0.3, 0.31, 0.3, well, went to 0.30. 0.15 was a 0.154, so yeah, pretty much spot on. No worries there. Now, it's not quite putting out the power it says, so it's generally a bit low, around about 5% low. So when it says it's putting out 60 watts, it's around about 57. Down here, 80 watts was putting out about 75 to the coil. So it's firing just a little bit low. So if you find that you're setting, say, 30 watts that you would on another device, and this feels cooler, it probably is because it's just running a few watts lower, and just bump it up a couple of watts. That's actually also because a lot of other devices are generally a little bit high, so they'll, you set 30 watts and they'll actually put out about 33, 35 watts, something like that. So yeah, you might find a little discrepancy there, but not to worry. It's just the nub you're looking at on the screen. Just bump it up a couple of watts. The efficiency, pretty decent, pretty normal. The DC switcher mode converters generally have kind of a bell curve of their efficiency range, right down at their lowest loading. The efficiency drops off a bit. We can see that there at 5 watts, it's down to sort of 81%. In the middle is kind of where they're most efficient normally. So between, say, 20 watts and 60 watts here, we're looking at 93, 92, 91%, around the sort of low 90s, which is good. And it just starts to drop off a bit at the top there, 89. And that's a little bit more obvious as well with the 0.15 coil, drop down to about 87%. And yeah, with the 0.3 coil, we can see 76%, which is pretty low, but not many people run down at 5 watts. And as soon as you get up to 10 watts, it's already up to 86%. And I'm not sure, this might have been a bit of an anomaly here at 20 watts, showing 98%. It's possible, it is possible, but I might be a few percent off here. The meters I'm using aren't the most accurate. I do calibrate them, but don't have a whole lot of resolution on the 4 different meters I'm using. 92, 94, say between 90 and 94% for the most part, which is pretty much normal. It is good to see that it has got a boost converter in it, so we'll see up to 9 volts of output there. So that's good, it means you can get the power you want on a high resistance build. For a final roundup, let's just have a look at the main stats of this device. Charging for the USB charge function, overall good, I'd say pretty good. 4.203 volts maximum, 2.2 amps current, a little bit high. Very good efficiency, very high efficiency, 85 to 88%, and resulting pretty low component temperature at 68 C maximum. Overall, yeah, pretty happy with the USB charging. DC converter, 90 to 94% efficiency, which is pretty normal. Does fire a little bit low, around about 5%. The resistance read and accuracy is really good. And it is a boost capable DC converter, so you can see up to 9 volts at the output for your coil, which is great for driving those high ohm builds at sort of any wattage you want, really. Internal cell did pretty much meet up to what I was expecting, and was even a little bit better for the current rate. So 1984 milliamp hour capacity, which is pretty much on their 2000 milliamp hour. So I'm going to say they've rated this device honestly. Vaporesso, thank you. I'm going to estimate at 15 to 20 amp CDR, which is the kind of constant discharge rate. Hard to put a number on that. I'm going to say probably 60 watt or below is the way you want to go on this device, but actually the cell did perform pretty well under load, but did get a bit too hot at 25 amp, which is what the cell will see if you're going to try and run it at 80 watts. So yeah, 60 watt and below is where I'd stay with that. Low cell cutoff, pretty normal, pretty good, 2.9 volts under load, and it will actually start to throttle the wattage. At 2.9 volts, when the cell gets down that low, it will start to reduce your wattage to not let it go any lower than that. So I think that's good. That's good behavior. Once the cell hits 3.3 volt resting, it'll say that's it, low cell warning, and it won't let you fire at all. So that's what I'd call the hard cutoff, and that's pretty good. 3.3 volts for a LiPo cell. We don't generally bring them down as low as 18650s or the other chemistry cells. So 3.3 volts is where you want to be on that one. Standby draw, 99 milliamps when it's active with the screen on. A little bit higher than normal, but not too much. You know, I'd often see kind of 70 milliamps around about that, but 99 is not too bad either. And it's not on active mode for too long. You know, it's only while you're really using it. So yeah, no big deal. And 14 microamps at the full standby draw. So this is when the device goes to screen off and goes into a full sleep mode. The current is 14 microamps, which is tiny, so nothing to worry about. And this is also really important for internal cell mods, where it might be a little while in between manufacturing the device and you actually buying it. Could be on the shelf, or you know, stocked somewhere for months or maybe a year even at some points before you actually even get it. So that's really important to know that it's not discharging the cell in storage, because if it does that and brings the cell down too low, by the time you get it, the cell could be stuffed, and yeah, we don't want that, obviously. So yeah, pretty good. And it does this 14 microamps pretty much right after the screen goes off, so it's not sitting there in active standby like some mods do for 5 or 10 minutes. It's pretty much straight after, and that is a good thing, so not wasting a whole lot of battery power in standby draw. So yeah, overall, I've got to say pretty good as far as all the stats. The one thing I'll keep saying though is the juice ingress protection is not that great on this device. Not real happy with the MOSFETs being exposed around the switch that can possibly get liquid onto them. I think Vaporesso really needs to improve their ingress protection. So yeah, so as to protect the board better from any possible juice spills. So yeah, I'll let you guys make up your own mind whether you think it's a good device to buy, and I'll leave it at that. Thanks for watching. Cheers.